how to add polynomials. The rule for addition of polynomials is only like terms can be added, and that holds true also for subtraction. So what do you mean by like terms? So we can understand this better, let's begin visualizing polynomials. This is our visualization of one. Its side length is 1 unit, and its area is therefore 1 square unit. This is how we visualize x. Its length is unknown, so that is represented by the variable x. And its width is given to be 1 unit, the same as this blue square. Now for x squared is visualized as a square with a side length similar to this, x. So the side length is x, and therefore its area is x squared. So notice that the width of this variable x is 1 unit, and the side length of the square is x. So you have x by x to get x squared. Now going back to like terms, x and x are like terms, and you can see that when we visualize them. So this is the visualization of x, and this is the visualization of 3x. X means 1x, and 3x means 3 of the same kind, 3x. The numerical coefficient of x is 1. The numerical coefficient of 3x is 3. We are looking at this x and this x to determine whether the terms are like or not. They must be the same variables raised to exactly the same exponents. In this case, our exponents are 1 and 1. These are like terms no matter what their numerical coefficients are. And if you are going to add x plus 3x, we simply combine them and count how many of that kind are there all in all. In this case, there are 4 x's, and therefore you now say that x plus 3x is equal to 4x. That is now what we mean by saying that only like terms can be combined. Now let's have another example. Let's say we have 2x and 3x. Again, we are looking at the variables raised to the same exponents. So if we now combine 2x plus 3x, here's the visualization. Combine them. That means addition. The result is how many of that kind are there? There are 5 x's. So you now have 2 of this kind plus 3 of the same kind equals 5 of that kind. And these x are just placeholder of a known quantity. Next, x squared plus 2x squared are also considered as like terms because you have a variable raised to exponent 2 and another variable raised to the same exponent 2. So we have the same variable raised to the same exponents. The only difference is that the numerical coefficient of x squared is 1 and the numerical coefficient of 2x squared is obviously 2. To get their sum, here is the visualization. We combined 3x squared, and therefore the result is 3x squared. So 1 square plus 2 squares equals 3 squares, and these squares have the same dimension, x squared. So this x squared is this 2x squared is represented by this 2x squared, and the sum would be the combination of these 3 squares. Let's have another example. Let's say x plus x squared. Here you have a variable x raised to exponent 1. Here you have a variable x raised to a different exponent. It's 2 now. Therefore, they are no longer considered as like terms. And so if you are going to visualize them, notice that they are different. And when you combine them, the answer is still x plus x squared. There is no more simplification that we can do, and so the answer remains as x plus x squared. This is a very important concept because many students from elementary transitioning from arithmetic going to algebra, they always expect that the answer is a single number. That is not always the case in algebra. An example of that would be this case. When you can no longer combine x and x squared, do not combine them to say 3x squared or x cubed. That's wrong. Just write the answer in binomial form like this. So sometimes your answer could consist of 2 or more terms. The only test is if the terms are no longer similar, then stop combining them. That is already your final answer. Next, if we have this x plus x squared plus 3x plus 2x squared, let's visualize them. X is this, x squared is this square, 3x would be 3 of these x's, and 2x squared would be this representation. So again, only like terms can be combined. Therefore, let's rearrange them so that the like terms are together. Like this. So x plus 3x can be combined and the result is 4x. 1x squared plus 2x squared can be combined and the result is 3x squared. And this is now the sum of x plus x squared plus 3x plus 2x squared. So again, our answer is still a binomial because we can no longer combine these two. Let's have another example. Let's say we have x plus x squared plus xy plus 2x squared plus xy plus 3. Let's visualize them. This is x squared, this is xy. And xy is a rectangle with a length of x and a width of y, or vice versa. It doesn't matter whether x or y is longer than the other as long as you are consistent. Notice here that if this is our x squared, then this width here is the same dimension as this width. So this is x, this is also x, and this is a length y. Then 2x squared would be 2 squares like this, and xy would be similar to this again, and 3, we have this 1, 2, 3 smaller squares with a dimension of 1 by 1. To perform now the addition, we combine only the like terms. So let's rearrange them. So this is x, all of these are x squared, all of these are xy's, and all of these are the constants. So therefore, our answer would be x plus 3x squared plus 2xy plus 3. And that is now the sum of the expression above. Notice that our answer now has 4 terms. And we are okay with that because we can no longer combine any one of them. Then when your answer consists of 2 or more terms, by convention, we usually rearrange them in descending order of power. So from exponent 2, exponent 1 here, exponent 1 here, and exponent 0. So this is now in descending order of power. So let's have more examples of addition and subtraction of polynomials. This time, let's include subtraction. So this is again our representation of 1 unit. This is our representation of x, x squared, y squared, and xy. How about negative 1? How do we represent negative 1? We use color red to represent negative 1. It's still the same dimension, only that the color is now red. And so this is our representation of negative x, negative y, negative x squared, and negative y squared, and negative xy. When the color of our manipulative turns red, that is our representation for negative. This color coding is important because we are going to talk about what we call as the zero pair. If you have one positive, that is yellow, and another negative, that is red, when you combine positive 1 and negative 1, the result is 0. That's why we call this as zero pair. And so when you are combining polynomials and you have one yellow and one red of the same dimension, then you can simply remove them because anyway the value would result to 0. So let's have an example. If you have x squared and you have another red negative x squared, this also forms a zero pair, and you can cancel that out later on also, as long as they come in pair. So, for example, you have 2x plus negative x squared plus negative 3y plus xy plus 3x squared. How do we visualize this now? So 2x has no problem. It's 2 yellow x's. Negative x squared would be red, and negative 3x would also be red, the same dimension as x, but it's color red. xy is positive, so it's yellow, and 3x squared are also yellow, 3 squares of dimension x squared, and they are all color yellow. Now, in order to simplify this, that means combine like terms, we need to rearrange so that all the like terms are similar, but not only that, we are going to remove the zero pairs. Now, this is what happens. This x and negative x form a zero pair, so we can just remove them, throw them away. Its value is 0, it will not affect the sum. The same here. This is a zero pair, so we can eliminate them. Then for x squared and negative x squared, we have one zero pair. So again, remove them. Their value is 0. And what's left is the answer. So you have 2x squared plus 1xy minus x. That would now be the answer to this problem. And when you have plus negative, we can also write that as minus of that variable. So this is now our final answer. So notice now that when you subtract algebraic expressions, it's just a matter of finding all those zero pairs. And since their combined value is 0, then you just remove those zero pairs. Let's have more examples. Add 2x squared plus 6x plus 5 and 3x squared minus 2x minus 1. Let's visualize them. There are 2x squareds, there are 6x's, and 5 constants, and this is 3x squared. Now you have here minus 2x, so think of this as negative 2x, so it should be red, and you have minus 1, that should also be red. Then after that, we can simplify, combine like terms. So these are all x squared and there are 5 of them. So we write that as 5x squared. For the variable x, we have x and negative x and negative x. We can eliminate these 0 pairs. So remove them. What's left is we have 4 x's representing 6x minus 2x. So this is the result. And there's also another 0 pair here. 1 and negative 1 becomes 0. So 5 minus 1 equals 4. So therefore, this is now the answer. 2x squared plus 6x plus 5 plus 3x squared minus 2x minus 1 would now be equal to this trinomial 5x squared plus 4x plus 4. Now, what happens if we no longer have those manipulatives? How are we going to find the sum of this? The idea is line up all those like terms. We have here x squared, we have here x squared. These are like terms. The same here, x and constant and constant. Then just combine them. 2x squared plus 3x squared equals 5x squared. 6x minus 2x is 4x, and 5 minus 1 is 4. That is the same as the answer we arrived previously. This red one was arrived at using visualization, and this one is now arrived at using just algebraic manipulation. That is now what we call as scaffolded mathematics. We start with some visual help, and once we understood the concept, we can eliminate that scaffolding, that visualization, that manipulatives, so that you can perform the more abstract operations. Next, let's now practice without these manipulatives. Let's say we have 4k to the fourth plus 14 plus 4k squared plus negative 3k to the fourth minus 14k squared minus 8, and we want to find the sum. Again, only like terms can be added or subtracted, so let's identify the like terms. 4k to the fourth and negative 3k to the fourth are like terms. Their variables are k to the fourth, k to the fourth. Positive 4k squared and negative 14k squared are also like terms because the variable part, k to the second, is the same here, k squared. And all constants are like terms also. So we are going to combine the like terms. So they are now grouped together by shapes. The circles are like terms, the rectangles are like terms, and the hexagons are also like terms. So 4k to the fourth minus 3k to the fourth is equal to 1k to the fourth. 4k squared minus 14k squared is negative 10k squared. You can think of this as you have an income of 4, but your expenses is 14, so you are still negative, that is negative 10. And then copy the common literal coefficients k squared. Then 14 minus 8 is equal to 6. This is now our answer. Let's have another example. Let's say we have subtraction. 4k to the fourth plus 14 plus 4k squared minus negative 3k to the fourth plus 14k squared minus 8. Now, when this is subtraction, we do not invent another rule. Still, the rule is only like terms can be added or subtracted. There is only an additional step that you are going to perform. And that additional step is to convert this problem into addition, because by definition, we know that subtraction is just the addition of the additive inverse. So if we make this subtraction into addition, we are going to get the additive inverses of all these terms inside this parenthesis. So this negative becomes positive, this positive becomes negative, and this negative becomes positive. So this is now how this problem looks like. We copy all the terms preceded by plus sign, no problem about that. But when you have a negative sign turn to positive, change the sign of all those terms inside the parenthesis. So this is important, so let's look at this again. Originally it was minus, this is now positive. Originally it's positive, this is now minus. Originally it was minus, it is now plus. That is what we mean by subtraction as adding the additive inverse. From subtraction, that becomes addition by additive inverses of all these terms inside the parenthesis. And I would like to keep on emphasizing this. So once we perform that added step of converting from subtraction to addition, then we can identify the like terms. These are the like terms grouped according to shapes. And perform now the simplification. 4k to the fourth plus 3k to the fourth is equal to 7k k to the fourth, 4k squared minus 14k squared is equal to negative 10k squared, and positive 14 plus 8 is equal to 22, and therefore this is now our final answer. Notice that it's still the same procedure, only that we have to convert from subtraction to addition by using the definition that subtraction is adding the additive inverse. Next, let's look at some application of this. Let's say this is the problem. A rectangular garden has one side with a length of x plus 7 and another with a length of 2x plus 3. Find the perimeter of the garden. So what is a perimeter? A perimeter is the distance around the figure. So if this is x plus 7, this is also x plus 7 because opposite sides of a rectangle are equal. If this is 2x plus 3, the opposite side must be the same measurement because opposite sides are equal. And therefore, to find the perimeter, in the book, usually they have this formula. Perimeter is equal to 2L plus 2W because there are two lengths of the same measurements and two widths of the same measurements. But since we are still in addition and subtraction of polynomials, let's not perform the multiplication yet. Let's do the addition first. So we are going to add all these four sides this way. And this is application of addition of polynomials. We add all the like terms. 2x plus 1x plus 2x plus 1x is 6x, and add all the constants. So the perimeter is 6x plus 20. Now, how about if we use that formula, P is equal to 2L plus 2W? Let's see what happens. You have 2 times our length 2x plus 3 plus 2 times our width of x plus 7. Now here you have a monomial times a binomial. We are going to perform what we call as the distributive property. Here, you distribute the monomial factor to the binomial factor. So 2 times 2x is equal to 4x. Then distribute this 2 again, multiplied to positive 3. So 2 times 3 is equal to 6. Then go to the next monomial factor, multiplied 2x to get 2x, and 2 times 7 is equal to 14. So what happens is we distribute this 2 to the binomial and distribute this 2 again to the other binomial. The result would be these 4 terms. Then rearrange to combine like terms. So 4x plus 2x is equal to 6x. 6 plus 14 is equal to 20. You will get the same result as the previous one.